Hello, everyone, and welcome back. So, we are going to pull things together in this video and learn about, or just basically review. Okay, but this review is going to be a little different than most because we have learned so much in this unit. But the thing about matrices is it's very procedural, and you're following a process that you may or may not actually understand. So, it's hard to do that. That's why there are entire college courses dedicated to matrices. They're called linear algebra courses, and that's how intense matrices can get. So if you feel like you're not really understanding the why behind things, that's because we don't know enough math to really understand the ins and outs of matrices. We really just understand enough and only have enough time to go over your basics. Okay, so there are going to be four main things you need to know for your test. The first thing you need to know for your test is matrix operations. These are just like regular operations: add, subtract, multiply, and divide. So for adding and subtracting, my kind of reminders to you are that the matrices have to be the same size. So matrices must be same size. And then I'm going to put a semicolon in between and say that it is very straightforward. And what I mean by that, and the reason why I'm making that a point, is there are no flips or flops. So basically, you're not going to be flipping stuff around between rows and columns and back and forth and doing the opposite of what you think it's supposed to be and remembering a formula. It's just add or subtract them if they're in the same spot. So for example, I could do C plus E, and it would be 3 plus 6, negative 1 plus 5, 1 plus 7. Just ones that are in the same spot get added together. You do not have to do any flipping or anything. That's why they have to be exactly the same size. Multiplying is where all those flips and flops come in, and that's why some of us got a little confused on adding and subtracting at some point, because it's really easy to get these mixed up. With multiplying, the number, actually, I'm just going to go ahead and say this: the inside dimensions match. Okay, so for instance, if you have a 2 by 3 and a 3 by 2, the fact that there are two threes in the middle of that, that's what I mean by the inside dimensions. Okay, if you need to make a note up here that when you write the dimensions of a matrix, it always goes row by column. Go ahead and do that so that you have that information for later. And then going back to multiplying, you are going to multiply the first row by the first column. And basically the whole idea is that you're going row by column. Okay? And I might do an example of multiplication here in just a second. In this case, you are kind of flipping or flopping. Okay, and then I'm not going to rate this, but the inside dimensions have to match. If you line up the outside dimensions, then you're going to get the answer, how big the answer is going to be. Okay, and I'll do a multiplication example down below for you in just a little bit. Then there's determinants. Determinants is where you're doing the diagonals and you're going to end up subtracting them. Okay, so I'm going to call this the right diagonal. When I say right diagonal, I mean the one going down and to the right minus the left diagonal. And then in parentheses, I'm going to put products. Because what you're going to do is multiply, say, 5 times 4, 20, minus negative 2 times negative 1, which is 2. So this one would be 20 minus 2, which is 18. The same idea applies for the determinant of a 3 by 3, but you have to copy column 1 in column 2 first, and then you're going to multiply and add right diagonals minus multiply and add left diagonals. So what I mean by that is you're going to have multiple right diagonals, so multiply each one together and add them up. Do the same thing on the left and add them up, and then subtract your answers from the right minus the answers from the left. Okay? And then there's inverses. So first of all, you're going to put 1 over determinant in front, and then inside your matrix, you're going to swap the right diagonal entries and switch the signs on the left diagonal. Now, I know that this is not perfect notes. These are more just reminders if you already had a good idea of what was going on. This is not enough to fully teach you. Okay, so I'm going to come down here and I'm going to kind of go over some of the more important problems. If you would rather try them on your own first, pause the video here and go try them on your own. So I'm not going to do a whole lot of adding and subtracting because those are more straightforward. So for example, here you would multiply all of C by 2 and then add it to E. So like 3 times 2 is 6, plus 6 would be 12. Negative 1 times 2 is negative 2, plus 5 is 3. There we go. 7 times 2 is 14, plus 1 is 15. Negative 4, negative 2 times negative 2 times 2, there we go, it's negative 4. Negative 4 plus negative 3 is negative 7. 2 times 0 is 0, plus 2 is 2. And 2 times 3 is 6, plus 8 is 14. So notice how everything here was a 2 by 3. This was a 2 by 3, this was a 2 by 3, and this is a 2 by 3. Nothing changes when you're adding. Everything should all be the same size. Then let's talk about multiplying. For multiplying, B is a 3 rows by 2 columns matrix. So really you're taking a 3 by 2 times a 2 by 3 because you're multiplying these two together. What I meant up there about insides matching is these two have to match because this row, or the number of things in this row, are going to get multiplied by the columns. I'll explain what that looks like once I get it written down. Do not multiply unless you've written the matrices like this right next to each other, because if you do, you're going to get into some iffy areas and make small little mistakes just because you didn't write them together. And then what I mean by saying that you're going to multiply the first row by the first column is you're going to take these two and multiply them by these two. So these inside dimensions have to match because this one tells you how many numbers there are here, and this one tells you how many numbers there are here. So there have to be 2 in both of those. And then I'm just going to go ahead and put this out there right now. After I multiply these, my answer should be a 3 by 3. Because those are the outside. Because there's going to be, I'm going to have 3 rows, and I have to do it times 3 columns. So that gives me 9 answers. Right, so here it's going to be 12 plus 8. And then I'm going to move to the next column. And when I move to the next column, I'm going to move to the right in my answer as well. So now I have 4 times negative 1, which is negative 4, plus 0. And then 4 times 7 is 28, plus negative 4 times 3 is negative 12. And then I'm going to move to my next row. 3 times 3 is 9. 2 times negative 2 is negative 4. 3 times negative 1 is negative 3. 0 times 2 is just 0. And then 3 times 7 is 21, plus 2 times 3 is 6. And then you're going to take your very last row, which has a magical 0 in it. Zeros are very magical in multiplying because they always multiply to 0. Negative 1 times 3 is negative 3. I don't need to do 0 times negative 2 because it's just 0. Negative 1 times negative 1 is 1. 0 times 0 is 0. Negative 1 times 7 is negative 7. 0 times 3 is 0. And then I would need to add all of these together, leaving me with 20, 5, negative 3, negative 4, negative 3, 1, and 16, 27, negative 7. Like that. Okay? And then I'm just going to bring this out here. I'm not going to do this part with you. I'm just going to say a squared. Whenever you square something, guys, that means you're multiplying it by itself. So you need to take a and multiply it by itself. Okay? And then I'm going to show you what's going to happen if we were trying to multiply c times e. If we tried to multiply c times e, and I'm going to do this in pencil because I want to be able to erase it, I would take the first row of c times the first column of e. There are 1, 2, 3 things in C and only 2 things in E. So this puppy is not possible. Also, if I wrote out their dimensions, C is a 2 by 3 times E, which is also a 2 by 3. And these two in the middle, they don't match. That's why I ended up with 3 things over here and only 2 things over here, and they didn't line up. Okay, determinant of A would just be this diagonal minus this diagonal. So that would be 20 minus 2. And 20 minus 2 is 18. And then these two are the same, asking for the same thing, just one was with A, one is with D. These both mean determinant. So here, sorry about that, guys. So I'm going to copy down the matrix for D. And then what you do is you copy the first 2 columns and add them to the end again. That's what I meant by copy column 1 and column 2. The only reason we do that is to extend our diagonals. So then we've got these 3 diagonals going to the right. I'm only picking diagonals that have 3 entries. And then I multiply those. So 3 times 0 times 4 is 0. Negative 1 times 3 is negative 3, and negative 3 times 5 is negative 15. 7 times negative 2 is negative 14. Negative 14 times 2 is negative 28. And then I add all of those together. 0 plus negative 15 plus negative 28 is negative 43. Then I do the same deal, but going to the left. So I'm going to start in the middle with this right here. So I'm basically starting where I left off with my right diagonals, but I'm going to the left. And 7 times 0 is 0. 3 times 3 is 9. 9 times 2 is 18. And then negative 1 times negative 2 is positive 2. Positive 2 times 4 is 8. So for this one, I get 18 plus 8, which is 26. And then what we had set up above is you're going to do right minus left. So the right side added up to negative 43 minus the left side added up to 26. And negative 43 minus 26 is negative 69. And then the very last one on the right, this is a fancy way of just saying the inverse, which is where you do 1 over the determinant. And then what you're going to do is swap the right diagonal and switch signs on the left diagonal. So this is the same thing I wrote up there. I'm just showing you how to put it into place. So for A, guess what? We already found the determinant of A. It was 18. And then we're going to write the matrix next. And this is going to equal the inverse. So for A, you're going to switch the 5 and the 4. So the 4 is going to go here, the 5 is going to go here, like that. And then these two switch signs. So they both are going to become positive, since they were both negative already. And that is the inverse. And I know that the inverse is kind of tough because it's just a pattern.